Hey everyone, winter is staging a serious comeback across the eastern United States, and what's developing in the forecast models demands your attention. After weeks of warmth dominating the pattern, we're tracking a potential 1-2 punch of winter weather that could deliver significant impacts to areas that have been largely snow-free this season. The complexity in this setup is remarkable, with multiple pieces of atmospheric energy that need to come together in precisely the right way to produce major storms. Let me walk you through everything the models are showing and explain exactly what needs to happen for these systems to deliver. First, I need to address viewers in the western half of the country. The pattern simply isn't favorable for significant precipitation out there over the next 10 days. The European ensemble mean shows virtually nothing west of the Rockies outside of some rain and snow in the Pacific Northwest over the next few days. A dominant ridge of high pressure is going to park itself over the region and deflect storm systems away. That's why my focus today is squarely on the eastern United States where the action will be. The atmosphere is setting up a fascinating scenario with two distinct storm windows. The first arrives midweek, roughly Wednesday through Friday. The second follows over MLK weekend and into the following week. Both systems involve multiple pieces of energy that must interact correctly to produce significant winter weather. Understanding how these energy packets behave is the key to understanding why model solutions vary so dramatically from run to run. By the way, if you'd like specific weather forecasts for your region or city, please leave them in the comments. I'll answer them individually as time allows. Also, if you like the video and subscribe to my channel, you'd be very grateful. Now, let's move on. Let me show you what the latest GFS is depicting for storm number 1. By Wednesday morning, January 14th, energy is diving into the eastern United States. You can see precipitation developing, with rain across the southern areas and snow beginning to appear further north. The critical evolution happens Wednesday night into Thursday morning as the system intensifies. Watch what happens with the energy aloft. We have pieces of energy in the northern stream and pieces in the southern stream. How they merge together and where that merger occurs makes all the difference. On the latest run, the energy is consolidating nicely. The trough axis is starting to turn from positive to neutral, which is exactly what you want to see. When a trough maintains a positive tilt, storms remain relatively weak. When it goes neutral and eventually negative, that's when explosive development occurs. This run shows the energy phasing correctly, digging aggressively southward, and closing off over the Appalachian region. The result is significant snowfall across the mountains of North Carolina, Tennessee, Kentucky, West Virginia, and up into Virginia and Pennsylvania. The Mid-Atlantic corridor, including the DC area, sees accumulating snow, and the I-95 cities from Baltimore through Philadelphia and into New Jersey pick up meaningful totals. But here's the challenge. Earlier model runs showed a very different solution. The 6Z GFS kept the northern energy too far north, separated from the southern energy. They didn't merge until the system was already well offshore. That produced a weak low pressure that delivered minimal snowfall. The trough remained positively tilted even off the coast. That's the nightmare scenario for winter weather enthusiasts, where everything looks promising, but the pieces never quite connect. The European model from this morning shows a similar disconnect. Energy packets that should be merging together remain too far apart. The northern piece stays north, while the southern piece does its own thing. They don't combine until the system is way offshore, which produces nothing for areas west of the immediate coastline. The Appalachian Mountains pick up some snow from northwest flow, but the major metro areas see very little. What we need to see over the coming model runs is convergence on a solution. The ensemble guidance, which averages dozens of individual model runs together, currently shows weak signals for significant snowfall outside the mountains. That tells us there's substantial disagreement among ensemble members about how this system evolves. Some members are bringing these energy packets together correctly and producing big snowstorms. Others are keeping them separate and producing nothing. Until we see the ensembles come into better agreement, confidence in specific outcomes remains limited. For the first system, here's my assessment. The mountains are a lock for accumulating snow. Northwest flow will deliver several inches to the higher terrain regardless of how the coastal development plays out. For areas along and east of the Appalachians, we need the energy to phase correctly and the trough to dig far enough west. If that happens, we're looking at a legitimate winter storm for the mid-Atlantic and potentially into southern New England. If the energy remains disconnected, we get a frontal passage with minimal snow. The trend over the past 24 hours has been slightly encouraging, with the latest GFS showing better energy consolidation than earlier runs. But we need to see other models, particularly the European, come into agreement before confidence can increase substantially. Now let's talk about storm number 2, which would arrive over MLK weekend. This is where things get really complicated. The setup involves a big ridge of high pressure amplifying across the western United States, while multiple pieces of energy dive into the central and eastern portions of the country. For a significant winter storm to develop, those energy packets need to dive out of the northern stream, connect with southern stream energy, and consolidate over the Gulf Coast region or southeast. That would create a surface low tracking northeast with cold air wrapping in behind it. The problem with recent model runs is that the energy isn't behaving the way we'd want. One piece is diving through the Great Lakes, while another is getting strung out back toward the southwestern United States. That's the ridge out west, pulling energy back underneath it rather than allowing it to eject eastward. When that happens, you don't get energy packets combining to form a powerful storm system. You get a frontal passage with modest precipitation along the boundary. The latest GFS shows a mixed picture for Storm 2. There's definitely cold air in place, which is encouraging. Arctic air will be firmly established across the central and eastern United States by this time frame. Any moisture that can get pulled northward into that cold air has potential to produce snow. The model is showing some overrunning ahead of a positively tilted trough, which produces accumulating snow across portions of Texas, Arkansas, Tennessee, and into the Appalachians. Memphis looks particularly favored, but it's not the consolidated major storm that winter weather enthusiasts dream about. Here's what makes this second system so uncertain. We need to see what the first storm does before we can have much confidence in the second. How the first system evolves and exits the pattern affects how energy behind it lines up for Storm 2. Additionally, we don't have strong blocking to our north. Without high pressure over Greenland or northern Canada deflecting the jet stream southward, we have a fast flow pattern that's less forgiving of errors. Energy packets can race through without phasing correctly. A slower pattern with more blocking gives you a wider margin where even imperfect energy interaction can still produce significant storms. Looking at surface observations right now, the pattern is in transition. Heavy rain is falling across the deep south from Louisiana through Alabama and into Georgia. Flood watches and warnings are posted across portions of this region. The line of storms producing this rain has severe weather potential, with a tornado watch still in effect. Meanwhile, winter weather is already impacting the northern tier. Snow is falling from the Dakotas through the upper Midwest and into the Great Lakes. Winter weather advisories cover northern Michigan, and several inches are possible. This system moving through today sets the stage for what follows. Cold air is going to pour in behind this front, dropping temperatures significantly by tomorrow across the eastern United States. That cold air moderates briefly early next week before the first potential winter storm arrives Wednesday through Friday. Then, regardless of how much snow falls, another significant cold air intrusion arrives around midweek. Temperatures will run well below normal across the eastern half of the country heading into MLK weekend. So where does this leave us? For the first storm, watch the next several model runs to see if energy phases correctly. The mountains will see snow either way. The mid-Atlantic and northeast are on the bubble depending on exact storm track and energy consolidation. For the second storm, there's too much uncertainty right now to make specific predictions. We need to see how Storm 1 evolves first. The encouraging news is that we're entering a more favorable pattern for winter weather. Even if neither of these specific systems delivers a major snowstorm, the pattern itself is shifting toward conditions that support winter storms. Cold air will be in place. Energy will be diving into the eastern United States. The ingredients are coming together. What remains to be seen is whether they combine at the right time and place to produce the significant winter weather that so many have been waiting for. By Monday afternoon, we should have a much clearer picture of how Storm 1 will unfold. That will also give us better insight into Storm 2 potential. I'll be tracking every model run and keeping you updated on how these energy packets are evolving. The next few days of data will tell us whether this pattern delivers the winter storms the models are hinting at, or whether the energy remains frustratingly disconnected. Either way, cold weather is coming. The only question is how much snow comes with it.